Okay, so today I was going to start with a little bit of geometry and then talk about similarity type problems and percent type problems. So one of the things, we covered area and volume quite a bit and a little bit on perimeter. We haven't talked about the Pythagorean Theorem, I'm pretty sure. So the Pythagorean Theorem.
I've heard of it before, but I forget what it is.
It's specifically only for right triangles. And we know something is a right triangle when it's in that, well, anywhere in the triangle they have that right angle symbol. So we know for sure that triangle is a right triangle. And so April doesn't remember the formula. Naisha, do you remember what the Pythagorean Theorem formula is?
No.
Okay.
Can't think of it.
Does it have to deal with a P or something?
It does not, actually. You would think so, because a lot of formulas start with letters that have to do with the topic. This one is a squared plus b squared equals c squared.
Okay.
Oh, okay.
Yep. Sounds familiar, but it is hard to remember.
It's been years.
I am pretty sure you do have to have this one memorized. I'm going to pull up the reference sheet really quick to double check. Bring it over where you can see it. Let's see. Yeah, it is not on this formula sheet. So if you need to use Pythagorean theorem, they're going to expect you to have this memorized. So a squared plus b squared equals c squared means the sides of the triangle. All those letters are represented by the sides of the triangle, and specifically a and b are the legs, and c is different. C is the hypotenuse. So when you see that 90-degree angle symbol, the legs are the sides touching that symbol. This is a leg because it's touching the 90-degree symbol. 4 is also a leg because it's touching the 90-degree symbol. But the side across from it is called the hypotenuse because it's not touching. This 90-degree symbol never gets close to this hypotenuse. You could also think of the right angle symbol as like an arrow. If we draw a line here, it looks like this has an arrow pointing towards the hypotenuse. But I think it's easier to remember it doesn't touch that symbol whatsoever. So once you've identified those, you can plug them in. So what number should we plug in for A?
4.
4. Now, if you had said 8, you'd also be right. The 2 legs, you can switch the order and it doesn't matter. I can put 4 squared plus 8 squared, or I can put 8 squared plus 4 squared. Doesn't make a difference. The important one is the c squared, though. You have to put the hypotenuse in the right spot, but our hypotenuse is just blank.
Yeah, we don't know what it is.
We don't know what it is. So what do we use when we don't know what something is?
Just put a C there.
C, X, any letter to represent, hey, we've got to find this. So a lot of people like X because it's commonly used. You see it all the time. You can leave it C. Doesn't matter as long as you put a letter there. So now this side, we need an actual number for. So when it says 4 squared, what is that asking you to actually do?
Multiply.
Multiply 4 times 4. So a common mistake is people will want to do 4 times 2 because that's the 2 numbers you see, but it's saying multiply 4 by itself. So there's 2 4s written there. On the Desmos calculator, you can do 4 times 4, gives you the 16, or it has a squared button. This a squared will automatically put that 2 up above, get the same answer. So same thing for the 8 squared. 8 times 8,
64.
which is 64. Good. And we did the exponents before the addition because of order of operations. Anytime you have a whole bunch of stuff to simplify down, you have to follow that, please excuse my dear Aunt Sally, or PEMDAS order. So exponents came before the addition subtraction section. So we did the squared first, but we ignored that plus sign until after we did both squared. So then we add them together. And that's 80. Good. So then we come to a spot again where it gets a little bit different. We want to do an opposite. When we solve equations, you know, like if we have x plus 5 equals 12, we say, well, the opposite of adding 5 is to minus 5. Get our answer. We chose that opposite. Squared is very weird because it's a new opposite that you haven't seen quite as often. So you guys know what the opposite of squared is.
Divide.
Division.
Kind of. You're close. Division is a form of, what we need is a specific form of division. Just like 4 squared was a specific form of multiplication, we need one specific form of division called the square root.
Okay.
Oh.
Because division is already the exact opposite of multiplication. Square root. So you do have to watch out for that. This is a squared, or a opposite, that's hard to remember. It doesn't come up quite as often. We're used to just plus and minus, multiply, divide. It's another thing you kind of have to have memorized. So we square root the 80, and by choosing that opposite, that gets rid of that little 2. So then square root of 80, we need a calculator for. We can't do the square root of 80 without just plugging it in. I'm going to get rid of all my other entries. And the square root kind of looks like a check mark button. This little check mark brings up that square root, and then you type in the 80, or you click on 80, and it pops up the answer in that bottom right-hand corner. Oh, no, that's not the zoom in we'd need. Let me zoom in a little bit because Desmos is always so small.
8.944.
Yep. So it depends on where they tell you to round. They might say round to the nearest tenth or the nearest hundredth. So let's round to the nearest hundredth. Usually they don't want the entire decimal. So if we had 8.944, what does that round to if you're rounding to the nearest hundredth?
8.9.
You're gonna keep it the same.
8.9 would be tenths. If we kept it exactly the same how it's written, that is thousandths, tenths, hundredths, yeah. So this spot here, the 9 is the 10th spot.
Oh, okay.
8.9.
So 8.944.
894, good. It goes tenths, hundredths, thousandths. Yep. And then 10 thousandths. They skip a ones place. Yep. Yeah, it could just keep going. Usually it's these first 3. So our answer, and they'd probably write this little squiggle to say, we just rounded. It's approximate. There's really more to the decimal, but we don't want to write it out. We're going to round it. So they can also have you apply the Pythagorean theorem, but using a word problem, an actual situation. So a 16-foot ladder is leaning against a wall. So if we draw this situation out, we have a wall, And it can help to actually draw a picture for a situation like this. I have a wall. I have a ladder leaning against that wall. Doesn't have to be a super great picture, just ladder. And right now we know how long the ladder is. So the ladder itself is 16 feet tall. So now the next part, if the base of the ladder, so when they say base of the ladder, that's the very bottom part. If the base of the ladder is 10 feet away from the base of the house, how high up the wall is the ladder? So bottom of the ladder compared to bottom of the house, if we connect those bottom points, that creates a line that we know is 10 feet.
Right.
They told us so. And then it said how high up the wall is the ladder. They want to know, where is this?
So is that the hypotenuse? Hypotenuse?
Well, it is a line. We have to decide where the right angle is before we decide the hypotenuse. Last time the variable was the hypotenuse. It doesn't have to be the hypotenuse. The variable itself could be a leg instead of the hypotenuse. If we look inside the triangle, like this spot here, this spot here, this spot here, which one of these spots is a 90-degree angle? It meets kind of in a square shape.
It's the one towards the wall and the one long line towards the wall where the ladder's leaning up against.
So right down here.
Yeah.
Yep. So that's the spot that helps us determine the hypotenuse. The hypotenuse is the side not touching this angle in any way. It's not involved in making that right angle. So is the x, the 10, or the 16 the hypotenuse?
16.
16. So we have to have this formula memorized again. I actually almost always fill in the hypotenuse first because it's the more important part. I say, okay, I know the hypotenuse is 16. I'm going to take care of that. So what should we put in for A and what should we put in for B?
We put in 10 for A, and then we put the x times plus 2.
Mm-hmm. Good. Or if you wanted to keep it B, you could keep the letter B. It doesn't really matter what letter you use.
Okay.
So this problem is a little bit different. This time, the 10 and the 16, they're on completely opposite sides. We can't just combine them together. The last problem, I'm going to rewrite it, was 4 squared plus 8 squared equals c squared. The last problem, these two things are on the exact same side. It's a lot different if they're on opposite sides, if they've been separated. So we still start by taking care of those exponents. We want 10 squared. So you can type into your calculator 10 times 10, or you can actually just hit 10 squared, which is 100. Oh, I'm going to go back to black. 10 squared was the 100. And then 16 squared, same thing. We're just going to plug it into a calculator. You could technically multiply this out by hand, 16 times 16. Go do the long multiplication skills. Don't waste your time on that. You're allowed a calculator, I think, on most every problem. If there's a section without a calculator, they're probably not going to use such big numbers, so it wouldn't take quite as long.
We gonna root that already, or we gotta wait later?
Know whether you get the calculator the whole time or not?
No, I said the square root, so 16 wouldn't be like the square root of 16?
Not yet.
Okay.
That didn't come. So let me write this down really quick. That was 256. So let me go back to this problem we did. So good question. Where do we do the square root? So on this problem, we went through and squared each number first. We got it bigger because the 2 tells you to multiply it by itself. Then we got it down to just one number. That became only 80. and you didn't square root until you only had one number left. So we still have an issue because we have a number on the left side, the 100, and a number on the right side, the 256. We want only one number. So we have to do opposites. They are on opposite sides. We want to get this 100 and move it to the other side somehow by doing an opposite.
Subtract.
Very good. You are both correct. We subtract 100. By subtracting, it gets rid of the 100 on the left. 256 minus 100 is 156. Or just plug it into your calculator. Even if you feel confident on your addition and subtraction, it never hurts to check it in the calculator just to be safe.
Right.
And then now we say, okay, now I want to get rid of this little 2. So what did we say gets rid of that tiny little 2 up above?
Square root.
Square root. That's where we square root to get rid of that from the variable. So when the 2 was on a number, we could just do 10 squared or 10 times 10. When the 2 is on a variable, oftentimes you have to do that opposite to get rid of it. And again, that's not something you can really do by hand. If they had a square root problem like this, it would be on the calculator portion. So square root of 156, let's round to the nearest 10th this time. So 12.489.
It'd be good.
Sorry, say that one more time. It kind of...
13.
13 would be, well, actually, if we were rounding to the nearest whole number, it would stay 12. Next to a 12 is a 4. Yep.
Yeah.
But that would say the nearest whole number. If they want the nearest 10th, then we're thinking about the 4. Does the 4 stay a 4, or does it round up?
Round up.
Stays the 4.
Okay, 2 answers. One person says round up to 5. One person says stay a 4. Always look at the number next to it.
Oh, yeah. So, yeah, it would go up to 5.
Good. Rounds up to 5. So it's not the 4 itself that determines. The number you're looking at, we don't care what it is. It's the number next to it that you say, this is going to tell me to round up or leave it. Oh, yeah. And technically, we would use that squiggle symbol to say approximately. So there's our Pythagorean theorem problems. Something we haven't addressed recently is similarity. There are actually a lot of problems that you can use what's called a proportion to solve. It's a fraction equal to another fraction. So when you set up a proportion, you've got to have like things. One whole side is related to each other somehow. And the same thing with the other whole side. So let's read the question so we can make that have a little more context. In a shipment of 500 parts, 18 are defective. So the 500 relates to the 18 because they were connected. 18 of those 500 parts are defective. So we can set up our fraction. 518, they were related to each other. They're going to be one of our fractions. And 500 was the amount of parts. 18 was the amount of defective parts. So now we have to set up the second fraction, and it also has to have the relations going on. How many defective parts should be expected in a shipment of 800?
Okay, you just put the 800 on top, and then you're going to have to put X underneath because you don't know how many.
Exactly. So because we put parts on top and defective on bottom, we had to keep it parts and defective. And then they asked us how many defective parts for the actual question, so that's where our variable goes. There is some flexibility. You might not set up the problem the exact same way I did. Maybe you do 18 over 500.
I was going to say that because it's a bigger number.
Yep. you could have done it that way, but then how is the second fraction going to look if you started that way?
You put the x over 800.
X over 800.
And then I know you got to cross multiply with these.
Mm-hmm. So do you remember?
My daughter was doing this the other day.
It's a common thing, and you'll actually have more problems that can use this process than you might recognize. There's nothing that's going to say these are similar. Always look for those groupings of related things. You know, they said the word parts 2 times. They said the word defective 2 times. It has that set of groupings that are related to each other. So we said we've got to cross multiply to solve. When you cross multiply, you start at the bottom. Again, you can do either direction. You could start with the 18 first. I like taking the right side up to the left, but it doesn't matter as long as you're going across and up. So x times 500 can't actually multiply anything. One's a variable, one's a number. So we're going to leave it 500 times x. The other direction, we can multiply. 18 times 800.
I got 14,400.
14,400, that sounds correct. 64, yeah, okay, 14,400 is correct. So then our ultimate goal is to get x alone. How do we get rid of the 500? What opposite do we use? Subtract would be if there was a plus sign.
Divide.
Yep. Divide. We like it to be subtract because quite often it is. Honestly, a lot of the math problems, they try and keep it a similar pattern, but sometimes you get so stuck in that pattern that you keep doing it even when now you're needing a different setup. So this is probably going to be a decimal again. 14400 divided by 500. On the Desmos calculator, it automatically makes it look like a fraction, which is fine because fractions are really just division problems. So that still is actually dividing. So 28.8. Now, since this is a real life situation, 0.8 of a part is not useful. You can't use part of a part.
So you want to round up.
Yep, you want to round to the nearest whole number, and next to the 8 is another 8. So it rounds up to 29.
Yep.
Occasionally there's situations where you can't round up. You do have to think of the situation. If this had something to do with people instead, you can't take part of a person and be like, oh, now I have a complete person. You either have a person or don't. So very occasionally you'd be like, oh, even though technically, according to the math, I'd round up to 29, I can't round a person up, so I'm going to leave it 28. That doesn't happen very often, but it's something to watch out for.
But your closest answer would be 30 because the other ones don't even get to it.
518, 800. Let me double check I did all the math right. I could have written the answers wrong, is probably the likelihood. 14,400 divided by 500. Yeah, okay. So I entered everything in right. If that ever happens, you're like, double check. We're pretty close, so then 30 is the closest. They rounded to the nearest 10th. No, the nearest tens spot.
Yeah.
Tenths with the TH is the decimal, but 10 spot is the 10th spot. Okay, so Aaron drives 180 miles in 3.5 hours. At the same rate, how far will he be able to drive in 5 hours? So again, we're looking for that grouping. They talk about miles. They don't say the word miles, but they say how far, which is in miles. and they talk about hours, both of those. So if there's that grouping of two sets of like things, we set up our proportion. Hi, thanks for joining. Oh, I don't think she has her sound on. I'm going to send her a quick message. Oh, never mind, she got it. Thanks for joining today.
It says it's muted though.
Yeah, so if you would like to answer questions and participate, you can unmute yourself if you have a microphone. Not everyone has a microphone attached. Or if you just want to listen, you can just listen. Or if you want to answer using chat messages, that works as well. Also, you don't really need to have your video on unless you want to. I don't even have a web camera on my computer, so I can't have my video on, but really what we're looking at is you should be able to see my computer screen with the question up. So we were setting up this proportion. We found that we had two sets of similar things. They talk about miles and miles, hours and hours. We want to set up our proportion. What should we use for the left side of our proportion?
180 miles. But
okay.
How would you do the 3.5 hours though?
It's a good question. Any ideas?
Probably 3.5, maybe.
Uh-huh. So, but you guessed right. Sometimes you actually know more than you think. It's a common thing that I see in students all the time where they're like, well, I feel like I don't know this, but they actually do.
Well, my daughter had some similar problems to this that I had to help her out with.
Mm-hmm. It's good you got the practice in.
Yes.
So what if you didn't know 1/2 was 0.5? Anytime you have a mixed fraction like this, you can plug it into a calculator as 3 plus 1 divided by 2. Nope, I guess maybe it wasn't working for her. Let me close all these out. So if you do 3 plus 1 divided by 2, it will pop out the correct decimal version. But anytime you're working with something like that, if you're going to use a calculator, you do want to switch it from a fraction to a decimal. How about the other side?
Well, your hours you're going to have, which would be underneath, but you're not going to have the miles because it wants to know how far. So you're going to have to put X on top.
Good. So we have our proportion set up. Naisha, do you remember how we solve this proportion?
Yes. You're going to take 180 times 5.
Good.
And once we get that answer, we're going to divide it by 3.5.
Yep. So I did it in 2 steps last time. You're just saying, well, I'm going to keep that 3.5 on the bottom and just do it all at once. That works. You do have to watch out for if the variable is on the bottom, it can be a little trickier, but as long as your variable is on top, just do that. 180 times 5 divided by the 3.5.
And I can't see that.
Sorry.
I can see it now.
Maybe a little too far zoomed in. So the 257.14. Sorry, my mouse went wonky. Okay. So then what's the closest answer?
It'd be 257.
Good. While you're working through multiple choice problems, always look for answers you can eliminate. If you're driving longer, you're going to go more miles. So the 126 just doesn't make any logical sense.
Or you could just add up like how many hours.
Mm.
Do like the 3.5 hours because it's 60 minutes in an hour and do it that way. But it takes longer.
It does.
So what did we do? Did we divide
Yes.
3.5.
Yes. Sorry, I typed it in all at once. We did 180 times 5, and then I just typed in divide 3.5, but you can go to a separate line and do divide 3.5.
Okay.
Sorry, I did go through that pretty quick.
So that's why I was like, that's the answer. Okay.
Yeah.
I have a question.
Yes.
I was trying to help my daughter out with a math problem the other day, and she was trying to figure out how to add the fractions on the Desmos calculator.
On Desmos?
Yeah.
So when you add the fractions on Desmos, it's going to pop out the answer as a decimal. So you type in the first fraction, but it leaves the cursor on the bottom. So you have to click to the right to get it out from under the bottom of the fraction. Or you can use this right arrow button under the functions. That makes it move around the question, these arrows. Okay. And then you would say plus 3 divided by 4. And it pops out a decimal instead of another fraction. So the Desmos calculator is actually not great for adding fractions because it doesn't give you the answer in a fraction format. You kind of have to do it by hand.
Oh, okay.
And I'm pretty sure there's no extra feature. Yeah, it doesn't have any extra fraction feature. Yeah, that's my only, I wish they had a fraction feature where it would leave it as a fraction because a lot of calculators do.
Okay, so I was doing it right. I just wasn't getting an answer for some reason.
Mm-hmm. So on this problem, I'm going to give you guys a minute to try it out and see what answer you get. And this time there's no multiple choice, just you're going to get your answer. And they're dear, so let's round to the nearest whole number.
Okay, I'm looking for a pen and piece of paper real quick.
And just for the people who are just watching the video, you may want to pause and try the question yourself before we talk about the answer. So Naisha, what answer did you get?
I got 36.
36? Okay. So when...
I did get some type of answer. It was like 29, 21 or something like that. That was from the square root though, but then I forget what to do after that.
Okay.
Where's that?
Sorry, say that one more time.
Oh, no.
Oh, yeah, this problem does not involve square root, just to clarify that. This problem should only involve multiplication and division.
Okay.
Okay.
So when you're doing a free response problem, also think about the logistics of it. So the related part was 530 deer were related to 39 deer being tagged. There were more deer out there than they tagged. There was only a few deer tagged. So if they've tagged 215 deer total, your answer should be a bigger number for just the amount of general deer.
Okay.
Oh, okay. So then it is at the 113,950.
That sounds like a middle step of the problem. Your answer of 2921 is actually correct. So let's see how we get there.
Oh, okay. See, I did the square root to get that though.
Oh, I don't know how that worked out. Maybe it just was a random kind of coincidence because square root should not be involved. We only need these two fractions.
Maybe I had to set it up wrong.
It's possible. If you get one number out of place, it can throw the whole problem off. So how did you set it up? What numbers did you put where?
I put 530 over 39 equals 215 over x.
Okay. So you were so close. 530 over 39, perfect. The 215, I always kind of color code. The 215 is the tagged deer. It's got to be related to the 39 tagged deer. So it should have gone on the bottom level with the 39.
Okay. I know.
Okay. So when you divide that 113,950 into the 39, then that's how you get the 2921.
Yes. So it was x over 215. So you're talking about the 13,000 number because now we cross multiply. And 530 times 215 is, oh, not 13,000, 113,950. A pretty big number. Sometimes with this multiplication,
Divided by 39.
divided by the 39.
Okay. Now I see.
Okay. So if you, oh, sorry, go ahead.
No, go ahead.
Okay. If you think about the logistics, if you try and keep in mind of, well, this is actually being applied. So 2921.7 rounds up to 2922, just to,
Right.
So that's our final answer. If you think about how it's being applied and you say, go through the process and you get 36 and you're like, I feel like this might be off. Their tag there were 215. I expected an answer that was bigger. Then you can go back to the beginning and say, okay, well, what's something I can change? I started with 215 over x. I'm going to try x over 215 and see if this gives me a number that makes more sense with the question. So keep in mind the actual application of the particular problem and say, does this make sense? Like, let's go back to that ladder problem. One of the first problems we did, Pythagorean Theorem. If we went through the whole process and we got an answer of 50, we have a 16-foot ladder and we're saying it's 50 feet up on the wall. That's just impossible. There is no way a 16-foot ladder is going to be higher than its entire length unless it has magic powers and can levitate or something. It's got to be, yeah, it's got to be 16 feet or less. You're like, okay, well, that's off. How can I go fix this? So looking at the actual application and being like, okay, does this answer actually make sense with this word problem? And that process only works with word problems because if it's just a random problem, you don't have the context to be like, does this make sense or not? So the last topic I had prepared for today was working with percents. The Desmos calculator does have a good percent feature, so I wanted to make sure, I think we've seen it once, but I just wanted to make sure you really knew how to use it. So like I said, you can download that Desmos app and get some practice. So Kim has a coupon for 30% off on one item at her favorite store. She picks a skirt for $43. And notice how I'm underlining the important parts. Underlining can help kind of focus the problem and be like, okay, this is really important. So how much will Kim pay? It's also important to know what they're asking. How much money is she actually going to pay if she gets 30% off and then pays a 6% sales tax? So there's some extra. It's basically 2 steps. So if she's getting money off, let's think about the context. Let's think about, what do you expect? Do you expect she's going to pay less than $43 or more because she's getting money off? Less. She's getting money off. She's going to save money. We all like sales. We save money. So if you go through this and get an answer of like 60, you'd be like, okay, something's off. How can I regroup? So we want 30% of $43. We're going to figure out how many dollars am I taking off of the $43. So in how much?
Huh?
Oh, I thought you said what?
I got you, but I didn't know I was waiting for you.
Okay. So if you already, you know, lots of people know, well, I can do 0.3 times the 43. You can do it the normal way, or the Desmos calculator also has a percent feature. If you hit this function button, there's a whole bunch of weird stuff, but you hit over to miscellaneous, it actually has a percent button. So if you hit 30 and you hit the percent button, it says 30% of, and you just type 30% of 43. You don't have to do any math, you just type it into the calculator.
Wow.
So it's a pretty cool feature.
Okay, so you put the 30% at 30 in first, and then go to the
Yes.
button.
So in the Desmos calculator, 30% first, then of 43. If you forget, if you're like, do I put the 43 first or the 30%, hit the percent button.
Okay, I'm on a phone, so it's not showing up a percent. I don't know what to go under.
On your phone for the Desmos calculator, there is still the Funcs button. It's F-U-N-C-S instead of the whole word function, and it's above these arrows on the right still. It's still the far right. And if you hit Funcs, you have to tab over to miscellaneous. It just says MISC, but miscellaneous, and there's a percent button. So if you hit,
click it, I got it.
yeah. So if you hit the percent button, then you know, well, I have to make the percent go by the percent sign. So put the 30 first, and then type the 43. So $12.90 is how much you take off the price. That is not your new price. It's how much taken off. So how can we actually get the new price? 43, take away $12.90. We're taking it off. Off means do some subtraction.
Okay, so 40, 30, take away 12.90.
Oops, and
that equals $30.10, it says.
Yes. So the skirt is $30.10 before tax. Well, almost every state. Most states charge you a sales tax to make money for the state. So now you have to pay your sales tax. And we can use that percent button again. 6% sales of the 3010. So we do the 6% of $30.10. 1.806. That's the wrong direction. So money is special. They will never tell you where to round money. But this looks weird because that's not how we ever write money. How many spaces should you have in the cent spot to be correct money?
2.
2. So we've got to round. Anytime you work with money, you just have to automatically round, even if they don't tell you. So should that stay 0 or should that round up to a 1?
Round up to a 1 because of the 6.
Good, 1.81. So then the question is, how does that interact with the 3010? Just like before, we weren't done when we had the 1290, we had to minus.
You need to add.
Sales tax is adding on. Yep.
Yeah, you need to add it on.
So 3010 plus the 1.81.
$31.91.
Mm-hmm. Very good.
That's cheaper than $43.
Yep. Even with the sales tax, still cheaper. Again, you can do some process of elimination. You can take the context of the question and say, okay, $43, I only get 30% off. That's probably way too low, and that's probably way too low. Like you can eliminate those really, really low answers and be like, well, it's probably one of those two. And then you at least have a 50-50 shot, even if you're just guessing. Okay, so I forgot how long this question was. I'm not sure we'll have time to finish this before the end. I think I'm going to save this one to till next time. Creating an entire pie chart can take a little bit longer. You have to do a lot of work for it. So, since I was talking about guessing, at some point, you're either going to just be like, I don't know the rest of these questions, or I don't really think you're timed, so I don't think you should run out of time. But at some point, maybe you're left with 5 or 10 questions that you just don't know, and they're multiple choice. If you end up making guesses, always pick the same answer. Pick the same letter every time. There's actually math that proves, you know, if there's 5 answer choices and you pick A every time, the first option every time, you're going to get 20% of those correct. Or if there's 4 answer choices and you pick A every time, you're going to get 25% of those correct. So picking. So it's a good idea if there's just, you know, I have no idea on these ones. You can't figure out anything to eliminate. It's better to eliminate first if you're guessing. If you're just like, I'm going to completely guess on this. Eliminate stuff that doesn't make sense first. If there's any of it that you're just like, that is for sure not the answer, do that and then make your guess. But some questions, maybe you're just like, I have 100% no clue. On those, if you have a whole bunch of them, just guess the same letter. I don't recommend guessing. It's not a great idea. You'll get.
But if you're short on time, then
Yeah.
You want to guess.
Yep. If you're short on time, or you just are like, okay, I'm just have no idea on this one. It's a good tactic to at least get a little bit more points.
Yeah.
So we are done for today. Next week it's going to be 5 or 5:30 again. I kind of have to vary depending on other teachers' schedules since we're sharing this account now, but I'll send a message out with the new time for next week, and I'll send out the video link once it's uploaded. Thanks for joining today, and I'll talk to you guys next week.
Okay.
Bye.
Bye.
Bye. Bye.